Hey everyone, Chang here and welcome to my channel. This video is part of the practice problem video series. Now in these videos, I go over problems that I feel like highlight certain math concepts really well and problems that I feel like you probably would encounter in a standardized testing environment. Now, the best way to use these videos is that every time I introduce a problem, I need you to pause the video. Try to solve the problem yourself. Once you feel like that you got the answer or you're stuck and need a little extra hint, then continue the video. I feel like this way you will truly engage and try to understand the problem and the concepts each and every one of these problems highlight. Well, let's begin. So for today we're going to go over this problem. If x and y are positive integers and 46 to the x power all to the y power equals 46 to the 23rd power, what is the arithmetic mean of x and y? Well, first and foremost, when we look at any problem, we have to figure out what is it asking. We're talking about arithmetic mean. Well, that's the big vocabulary, but basically arithmetic mean is averages. So we're trying to find the average of x and y. Now remember, average is basically you get all the numbers you're worried about, you're going to add them together. Then you're going to divide it by the total amount of numbers you just added. So, since we're working with x and y and we're trying to find the averages or the arithmetic means of x and y, here's our goal. We're going to be adding x and y together. And we're going to divide it by the total amount of numbers we just added together. Well, we're only adding 2, so we're going to divide by 2. That's our goal here. This is what our final answer is going to roughly look like. Now, first and foremost, well, in this case, we have to figure out x and y. We know from here, x and y are positive integers, so we don't have to worry about negative numbers. Integers is basically 0 and all the whole numbers, so we don't have to worry about decimals or fractions. Great. Now we have this to worry about. We have 46 to the x all to the y power. Well, from properties of exponents, we know that we can rewrite this, and that's going to be 46 to the xy power, x times y. Now, the other side we haven't done anything, so we're just going to bring it down so that it's easier to see. 46 to the 23rd. Now, at this point, we're kind of stuck. Here's the sort of like hidden key that if you can see this, that's what makes this problem so easy. And it is this right here, the 23. 23 is a prime number. So what does that mean? When you try to break it down into smaller factors, smaller numbers that multiply together to become 23, it's not possible. The only factors you can break down 23 to be is just 1 times 23. So that's the key. It's a prime number. So 23 is basically just 1 times 23, right? Well, great. Now we know this. X times y is going to equal 23. We know it's a positive integer, so it can't be decimals or fractions. And we know that it's a prime number, so we know that the only possibility for x and y to be is 1 and 23. Now, for this problem, since we're adding them, it doesn't matter which one is x or which one's y. We just know one of them is going to be 1 and one of them is going to be 23. Well, that's going to give us this. Let's just do x as 1 and y as 23. So it's going to be 1 plus 23 divided by 2. Well, that's fairly simple. 1 plus 23 is 24, and we still have to divide by 2, and we want to simplify it further. 24 divided by 2 is just 12. Now, remember, for this problem, there are several components that make this work. First and foremost, x and y must be positive integers. If it's not positive integers, then this kind of reasoning wouldn't work. The other thing is that 23 happens to be a prime number. The 46 is there to distract you. You could change that to any number you want. But the 23 is the focus. Now, if it happens to be that 23 is not a prime number, let's just say, for example, it's 15, then this problem wouldn't work as well because you're not sure what x and y could be. It could be any possible combinations that would multiply to be 15. Well, if they happen to have something like this, I can imagine, I'm just guessing, a different version of the problem. If this is not a prime number, they will probably have to ask you what is the largest possible arithmetic mean or the smallest possible arithmetic mean, right? If they don't ask you something like that, or actually lastly, if they happen to have multiple choice and only one of them would work, then I can see this problem kind of working. Although I wouldn't say it's a really good, well-written problem. So hopefully this helps. If you have any questions or any problems that you would like me to work out in a future video, please put them in the comments. Well, have a wonderful day.